Good day, everyone. My name is Andrew Friskup. I'm an extension plant pathologist and associate professor in the Department of Plant Pathology at North Dakota State University. And today I'm going to give you an overview of the wheat diseases we have in the north central US. And what I'm really going to try to highlight is give you that survey of diseases that you may find out in the field, and then give you a little bit more information on how they impact agriculture, but more importantly, and how you can identify them. The outline, we want to highlight only the common diseases. Now, there's a lot of wheat diseases we have in the north central region, but I'm going to kind of stay on the ones that we commonly have as far as conversations with the colleagues I have across the states. The idea with this presentation is going to be grouped by plant part. So I'm going to start with kernel diseases and then end with diseases that impact the head of wheat plants. And I am going to provide a little bit of management information, but I'm not going to be too specific. And the biggest reason why is I always encourage you to contact your local extension, whether if it's an agent or an area specialist or state specialist or land grant university for more precise recommendations. And those are some things, but I'm just going to give you a little bit about how we can manage some of these diseases. There are a couple of great resources that I use personally, and I encourage you to at least reach out to. One is the Wheat Disease Identification Pamphlet. This was produced by a group of plant pathologists in the NCRA 184, which more or less dedicate towards the management of small grain diseases. This can be found on the Kansas State University Extension website, and is a good visual resource of what some of these will look like. We also have a Farmer's Guide to Wheat Diseases that was recently published. This is through the American Phytopathological Society meeting, and again, a group of plant pathologists that work on wheat came together and wrote a book really from the viewpoint of agriculture professionals and growers. The last resource I want to highlight is the Crop Protection Network website. It has a variety of information on small grains and specifically wheat. You'll get a variety of photos, you'll get fungicide information, and it's something that I would encourage you to look at if you want to dive into these diseases a little bit more than what I'm going to be able to cover today. So with that being said, let's dive into this presentation. The first one I want to focus on are kernel diseases, since that seems like an obvious place to start when we're putting that seed into the soil right away in the beginning of the season. Now, what I am showing you here is a kind of a 5 seed lots is what we call them. Here on the very far left, we have a healthy kernel of wheat, and then we're going to go through 4 other potential diseases that you may see in the seed lot or on the kernel. The first one is scabby seed or Fusarium infected seed. Now, this is a result of a disease that impacts the head, Fusarium head blight. So we won't go into the head part of this, but the idea is when you have scabby seed, it's lifeless, it looks chalky. Some cases you can have red or pink hues to it, which is more or less the Fusarium fungus. And this disease can impact germination and can lead to seedling blight. So something to keep on a lookout. Again, if you had a field with Fusarium head blight, it's likely you're going to be seeing this in the seed lot. Another very common one is black point. Here you have a discoloration on the embryo of the kernel, and this could be a result of a variety of pathogens, most of them being saprophytes, meaning that they're just colonizing dead or decaying tissue. We see this more frequently when we have delayed harvest, so wheat that's been standing out there past ripe. If you get additional rain, you're going to see the development of more black point. Again, this can provide some impact on germination, but we don't see much of a yield hit with this one as far as this disease. Common bunt is a seed-borne disease where the what I call the inner kernel of a wheat is displaced with black dusty spores. Now this disease is a little bit unique in how you can identify this both visually, but also using the sense of your smell. This disease or this pathogen does produce a oil that more or less smells like fish or rotting fish in a lot of ways. So it's something that you can really pick up, and personal reflections, once you smell this this type of fish odor, you always something to remember. Now this it can be more common depending on the area of the north central US. For example, up in North Dakota, we don't see this disease all that much, but in other areas, you might see it more frequently. The last one you might see in the seed lot is the ergot, which are these dark, hard, black to purple fruiting bodies. Now, this is a head disease that more or less results into the pathogen being in the seed lot, but just wanted to give you what it looks like comparison to everything else. And this is another head disease that will provide a little bit more information towards the end of the presentation. Another common seed-borne disease that we don't see until the wheat starts heading out is loose smut. In these photos here, you're going to see that the spike of the small or of the wheat head is going to be completely displaced with black dusty spores. Uh, when you start getting those winds that come later in the season, it's going to completely displace those spores and they start causing new infections on developing kernels. Like I said, this is a very common disease. We see it every year. In some cases, you can find it in every field. And when somebody asks me about yield loss, when you have one wheat head impacted, it's 100%. But across a field scale, it can be pretty minor in a year, especially if you only find one or two plants and when you're planting 1 million to 1.5 million of plants per acre. So again, something you can commonly find, often leaves an empty rachis, and it's one of those diseases that you will be able to find easily. So what is the management of kernel diseases? First and foremost, clean and certified seed is always what we practice to help avoid some of these kernel diseases. Fungicide seed treatments work very well, especially on loose smut is one of our primary management tools to really reduce any impacts from that. They don't work as well as like on ergot bodies, for example, would be something that they don't have much of an impact on. I put in a question mark by variety resistance as because there are some of these kernel diseases that do benefit from variety resistance, but like black point, for example, there's really no variety resistance for that. So I'd say in some cases, but it's not a uniform type of recommendation that you can use variety resistance for every one of these kernel diseases. The next ones I want to look at are the seedling blights and root rot. So as our plants are developing in the field, some of the things that we can look for. Now, when it comes to root rots, there are several out there. One of the first two that I'm going to be focusing on first is Fusarium root, crown, and foot rot. Now, when it comes to root rots in the general sense with wheat, often we don't see the impact until later in the season, often until the heading stages, where we'll see complete bleaching of a stem, leads to an empty head, and you won't get any grain fill. So in that first photo, which I'm using my hand to show, is 3 wheat plants that are more or less side by side each other, one not being impacted by root rot, and the other two do have some problems with root rot because you see that bleaching of the stem resulting in a sterile head. With Fusarium root and crown rot, another thing you can look for is the fungus itself. In this close-up photo, you're going to see that pink red fungal mass that is being produced near the crown of this plant with a little bit of a discoloration on that crown. Again, when it comes to diseases, seeing that sign of the pathogen is a very true way of determining what is causing the symptom in a field. Another type of result when it comes to Fusarium crown rot is you'll have a very reduced root system in general. On this photo, on a close-up, you're going to see that root mass below where that seed is. It's very not well developed, and it's something that you can look for. Now, when it comes to Fusarium crown rot, and then the other root rot, we'll talk on common root rot. They are favored by stressed environments. So, for example, in your drier climates or the ones that might go from a wet cycle to an extreme dry cycle, like you have in some of the western parts of the states in the north central, in the Great Plains, you're going to see root rots be a little bit more problematic. So they take advantage of a weakened plant more or less, and by the time that plant heads out, they're choking out the nutrient flow, almost like a vice grip when it comes to impacting the vascular flow up to the head. Common root and foot rot. Again, this is caused by a different pathogen, caused by Cochleobolus sativus. But in this case, what you're looking for are these brown to chocolate discolorations. A lot of times we find these on the subcrown internode, meaning above where the kernel's at to where the crown of the plant below ground. In this photo, you're going to see a variation in severity. So on the far left, you have a really relatively clean, healthy looking subcrown. And as you move left to right, you're going to see some more discoloration. Again, these plants are going to be in that late tillering stage. When I pulled these, you didn't see much above ground symptoms, meaning that it acts very similar to what we see with Fusarium crown rot, is it's more or less slowly choking off that nutrient supply. So by the time you get to that head emergence, you're going to have a sterile head formed as well. So there's some characteristics with that. Again, like Fusarium crown rot, this is going to be favored by some of your stressed environments, specifically when you see those drier environments or you taking advantage of a weakened plant. What we look like, how these look like into a field, we tend to see these in patches. So what I'm highlighting here is you have a couple wheat heads that have white heads on them, and there's a variety of things that can cause white heads. But in this example, if we would pull up these plants, we saw a bleach stem, we saw the bleach head as in only in some small pockets in the field. And when we started looking at the subcrown or the crown area, you see discoloration. This is kind of a way to take it from the field to diagnosis as far as what this disease looks like. I will remind you that often in root rots, we have a complex, meaning multiple pathogens can be the cause of it. It's never really a sole pathogen leading to this. Maybe there are some exceptions in a few cases, but for the most part, we're dealing with a variety of root rots that have a very similar pattern in the field, but also being able to cause that discoloration. When it comes to management of root rots and kind of looking at these two in general, we have other ones out there such as Take-All, Rhizoctonia, and Pythium, but for the most part, these last two are the ones that most frequently get brought up in conversation. There are some programs that have looked at variety resistance, and you'll notice a theme throughout all this. Variety resistance is a cornerstone of management in wheat, as well as other crops we grow. Cultural practices can have an influence, and this is more relying on crop rotation. In some cases, planting date has been encouraged, and the effects of tillage is a little bit unclear, maybe inconsistent, where they think crop rotation is more of a better option. And then fungicide seed treatments can provide early season control. Again, these don't have a season long effect. I often like to look at seed treatments providing that first 3 weeks of that seed that is germinating and developing from protecting from any pathogens. Once you get outside that window, you lose that effective residual, and you can have some of these colonized later. And as I've been seeing in some of those photos, that slow colonization, you could tell that they can impact the roots at any time during the season. So again, some just general management. Contact your local extension for more precise recommendations. Next one I want to touch on is viruses. And these are often what we find in the early vegetative stages. The first group or complex of viruses, I think I've just kind of grouped them all together, are wheat streak mosaic, high plains disease, and triticum mosaic. Again, these can often also occur as a complex, meaning multiple viruses can be found in the same plant. One of the characteristic symptoms of this is you see streaking, you see yellowing, you see stunting very early in the season. Now with viruses, they can be confused with other abiotic stressors such as nutrient deficiencies. So there are a few key themes that you can look at. One is to look at the pattern in the field. If it's more irregular, if it's falling from a leading field edge, if it's fallen in an area of last year's volunteer wheat, you're going to be able to find likely be able to start using those agronomic factors to figure out what is a virus disease and what it looks like. Showing an example what this might look like on a field shot. Here you have an area that is yellow, it is bare, and as you go extending out into the field, you see it's a little bit more greener. This is an idea where you could see this the wheat streak mosaic complex being started from a field edge. The other factor when it comes to the wheat streak mosaic, high plains, and triticum mosaic is they need a vector. And the vector in this case is a wheat curl mite, a small wingless insect that survives very well into the crown of the plant during the winter. And you're going to see as we talk about the management, one of the key things is to prevent this curl mite and more or less the virus from having a food source before the subsequent winter wheat crop is starting to emerge in the fall. We can also see in some cases, we could be field by field. You can see one side on the left-hand side is a lot of wheat streak mosaic. Again, that same yellowing bare patch pattern. Across the prairie trail road here, it's going to be greener, and it's likely we're going to see this virus move. So I'm just using this photo as an idea that if you do find virus in the field, because you're dealing with wheat curl mites, they can travel distances and start an epidemic in a neighboring field. Our management for this, and I'm going to highlight this one a little bit more because it comes to viruses, we have very limited tools what we can use. And you may have heard of breaking the green bridge, and this is very key to being able to help disrupt an epidemic from wheat streak and the other mosaic complexes from developing. And this is making sure there is a period of zero green host material for 2 weeks before those plants start emerging. So in the fall, for example, if you're in a wheat on wheat system, which I'm trying to depict here, you got to make sure those volunteers are killed, because if those volunteers are around, the wheat kernel mite, the virus can survive on that. And as the developing crop comes up with the winter wheat, they can transfer, and then you're going to start the problem early in the season, and you're going to be dealing with it next year. So break the green bridge, a very big cultural practice that can be used to disrupt the cycle for wheat streak mosaic. Another common virus disease is barley yellow dwarf, caused by the barley yellow dwarf virus. This one is vectored by a couple different aphid species, cereal aphids. Just a couple examples up there. Bird cherry oat and English grain aphid are two of the more common vectors for this. What you'll see in a field is often the flag leaf starting to yellow. In some cases, it may turn purple, but you're going to see it in patches, almost similar to what you'd see with an aphid feeding. Now, as you go further south in the Great Plains, you can see more issues with barley yellow dwarf, especially in the winter wheat crop. As you move northward into the spring zone or spring wheat growing regions, we don't see this disease all that much. Because the vector doesn't overwinter in North Dakota, so we're reliant on those southerly wind currents to carry the aphids, but also the virus in this case. Here is a close-up of what barley yellow dwarf infected plant or virus plant may look like. You see that purple, reddening, yellowing on the flag leaf, starting from the leaf tip, kind of extending down. It's a very character symptom. Again, another virus. It's always good to be able to get it tested. And I didn't mention this earlier, but when it comes to wheat streak mosaic and barley yellow dwarf viruses, you can send them into a plant diagnostic lab to confirm that you have a virus issue in the field. And that is the most concrete way you can determine to make sure that you are avoiding future damage with some of these virus diseases. So management, first thing you got to diagnose it, and that's where I'm mentioning send that leaf sample in for a test. There are variety resistance, but that's not available for all viruses and in all market classes. The cultural practices is what we really rely on. Mentioned breaking that green bridge is very key for wheat streak mosaic and the complex of mosaic viruses that occur. And oftentimes there's a question about using insecticides or caricides, and they're generally considered ineffective, with the idea of being able to manage the vector would help manage the virus, but most of the work suggests that it's can be very inconsistent and therefore not something that we look at for recommendation. So for fungal leaf spots, as far as the next disease that you may likely see in the growing season, we have a couple very common ones. The first one is tan spot. And as you see, as we go through these 3 fungal leaf spots, they're gonna look very similar to each other. So there's trying to highlight some of the things and how you can help differentiate. With tan spot, it's gonna be ellipsoid lesions with a tan center, as the name suggests. Oftentimes they can start out as a black dot, and they eventually form some of these early infections of a yellow halo with a brown center. You can see some more advanced lesions here. And the idea is they love cool, wet weather. So this is a disease that you can find fairly early in the growing season. The 2 other fungal leaf spots, Septoria triticale blotch and Stegnospora nodorum blotch, here you're going to use some characteristic symptoms. Now, differentiating between Septoria blotch, Stegnospora blotch, and tan spot early in the season is very difficult. As the lesions get more advanced and more mature, you can start picking out differences. For Septoria triticale blotch, you're going to see these black fruiting bodies in the middle of the lesions, which are more or less holding a spore source for future infections. With Stegnospora, you can also find fruiting bodies that tend to be a little bit more brown and not as apparent, but the presence of fruiting bodies is one way that you can differentiate these 2 diseases from the previous one, tan spot. Steganospora leaf blotch can also lead to gloom blotch lesions on the head. So how I'm using this in this reference is that if you have a Steganospora problem on the leaves, you're likely to see some of these purple blotchy to brown lesions develop on the head. As with you saw with the viruses and the root rots, we often think about complexes, and fungal leaf spots are no different. In some regions, you may have two of these that occur frequently side by side. Sometimes it may be reserved to only one of the fungal leaf spots that you're worried about. But the idea is that you're likely going to have multiple fungal leaf spots, even on a single leaf with this. And we look at and manage this as a complex. And luckily, a lot of our fungicides are still effective in managing all three of these fungal leaf spots, and something that, it's almost like a universal type of management recommendation. And there's also variety resistance with it. Another disease, foliar disease you may see is powdery mildew, another very common one. Often seen it earlier in the growing season when we have cool, wet, and high humidity. You have white, fluffy growth is the best way to describe it. Sometimes it could turn gray. As the fungus matures, you can see the development of black Clystothecia bodies and developing in the middle of the mycelium. And it's something that once you see it, you're going to be able to differentiate it each time in the growing season. So some general recommendations for management of fungal leaf diseases. You have variety resistance, again, a big cornerstone, and you're going to see that likely apparent across all market classes. Cultural practices do help. Crop rotation, again, one of our oldest management tools, are very effective in managing fungal leaf spot diseases. And there are several effective fungicides out there, and generally the same fungicide can manage all of the previous 4 diseases that I just described. I also want to touch on bacterial diseases because there are, in certain growing regions, we do have some significant issues. Right now in Minnesota, South Dakota, and North Dakota, we're seeing a very high rise in the amount of bacterial leaf streak. As the name implies, it is caused by bacteria, and you're going to see water soaking on these lesions on the very far left-hand side photo early on. As those lesions mature, you're going to see necrosis develop, and you're going to see the sign of the pathogen, in this case, the bacterial ooze coming out of the lesions. Eventually, this leads to necrotic areas on the flag leaf, and you can see some pretty significant damage on that flag leaf, leading to reductions in yield. And again, this can be found in most of the regions in the north central, but right now there's a few areas, a few states that are having some significant problems with this disease. This one also can lead to some development of lesions on the head, known as black chaff. So if you see bacterial leaf streak on the flag leaf, it's likely you're going to see that the bacteria splash up into the head and lead to purple discolorations. Now, this one can look very similar to gloom blotch, but one way to look at it is to look to see what type of diseases are on that flag leaf, and then look for the purple discoloration below the head, which is often a diagnostic feature for this disease. Management of bacterial diseases, variety resistance is our most important management tool, especially for bacterial leaf streak. It's right now our only consistent management tool. The other 2 suggestions, cultural practices and clean seed, do help, but it's tough to quantify what we can use, how we can detect it, and how impactful it is. So it's a little bit of a gray area in research right now, but we do know variety resistance is the one thing that we can definitely put our efforts in. And then we often get questions about using copper applications for this. So applying a copper-based product to help reduce bacterial diseases. And most of the research out there suggests it's very inconsistent at this point and not something as far as a recommendation for management. We have a few rust diseases to consider. One is leaf rust, and this is going to be defined by these more circular pustules that develop on the leaf. It's going to be more orange in color. It can be brown depending on the variety and location in the US. We also have stripe rust, which is more yellow orange, and as the name implies, forms stripes on the lesions in linear fashion. I often think this kind of looks like Cheeto dust when you first observe it. And we also can see stem rust, which for the most part is going to be contained on the stem of the plant, but it can also be found on the head and also on the leaves. But for the most part, you're going to see these more of a brick red type of pustules with some obvious tearing in the stem tissue itself and its stem rust. So when we look at the rust diseases, again, depending where you're at in the north central US, all these are going to be overwintering in the south. And as we have southerly windstorms or rainstorms and southerly currents, it blows these spores northward, and then we start dealing with it. So up in North Dakota, we're often the last to harvest, but we're also the last to see some of the rust diseases occur in our state. The closer you are to where these overwinter, so we're going to use, say, Kansas, for example, a very big wheat producing state, you're going to see the stripe rust and leaf rust being more problematic, being able to occur earlier in those states, relatively speaking, the growth stage as you think about the other states north. Management, variety resistance. There's a lot of single genes and also adult plant resistance out there to manage these rust diseases. Fungicides work very well against rust diseases. It comes down to timing. Flag leaf application of fungicides is what is recommended across most of the region. And cultural practices, depending on the region, and this is more or less that as the further north you are, the earlier you plant your crop, the less risk you're going to get hit with a rust disease that occurs later in the season. So again, not a tried and true management thing for a tool across the whole North Central, but just something to kind of think about a little bit outside the box. The last couple of diseases we're going to highlight are head diseases and kind of bring this presentation to a close. The first one is our most important head disease and arguably the most important disease in the U.S., and that's Fusarium head blight. We generally see this disease when we're getting about 10 to 14 days past the flowering stage of wheat. You're going to see premature bleaching of a spike. Sometimes it can be a single floret, can be half the head, can be the entire head. It really depends on the time the infection occurs or how many spores are able to have successful infection. If you go out on dewy mornings, sometimes you can see the presence of the orange, the salmon colored Sporodocia or asexual mycelial fruiting bodies here. And this is one thing to kind of separate it from any other causes of whiteheads. So if I mentioned earlier that root rots can cause whiteheads, the difference is that can be the entire stem leading to a completely sterile head. With Fusarium head blight, you're looking for those plants that have a portion of the head or all of the head, but also is accompanied by some of the, in this case, the pathogen being able to show its sign. Ergot, again, mentioned earlier in the topic, it's one of the oldest documented diseases. It has a very wide host range. It's anything from quackgrass to brome grass, but to also all the small grain crops that are grown in the North Central. In this case, the pathogen infects the female flower, replacing where the kernel really develops, and you get these irregular, hard, dark, black sclerotia bodies. And sometimes you fall off into the ground and you don't have to worry about it or get displaced during the harvest process. But for those that make it into the hopper or into the bin, it's where we start leading to reductions in quality. So this pathogen releases very strong alkaloids, a reason why they have very strict thresholds on it. Didn't mention earlier, but the Fusarium head blight disease also can cause yield loss, but the other thing that it produces is a mycotoxin, which again reduced quality. So with these two specific head diseases, not only can they result in some yield loss, but the quality reduction is often what we're dealing with as far as at that point of sale. The last one I'm just going to touch on is sooty mold. It's a very common question we get. It's not really a disease is what I call it, because it's the result of a very late harvest again for wheat that's sitting on the field, and you have saprophytic fungi colonizing the head of it, leading to a very black, dusty type of spike. In some cases, it can lead to a dusty harvest, can impact by having some more black points in the bin, but for the most part, it's more of the fungi taking advantage of a dead and decaying host. So what we look at for management of head diseases, variety resistance for Fusarium head blight, that is our most important tool. We don't have complete resistance for Fusarium head blight, so we look at this as just a way to help reduce those potential impactful levels caused by the disease and the mycotoxin it produces. Fungicides work very well for Fusarium head blight and when used with a resistant variety. So in some cases, the best variety with a well-timed fungicide application for Fusarium head blight, you can reduce disease by up to 70%. And similarly, you can see that same reduction in the mycotoxins they produce. For ergot, we don't know much about variety resistance. There's not much out there, and fungicides don't seem to work either. So that's a disease that's a little bit difficult to manage in season. We do have cultural practices in place. Again, looking at crop rotation as being key for managing in-field inoculum. We know that the Fusarium pathogen does release spores, and they can travel quite a far distance. But the idea is just to reduce that amount of inoculum within a field for future years. Again, tillage is another way to help reduce of infected grain residue, such as small grains and also corn residue, from being the source of inoculum for Fusarium headlight. So again, very general. You're going to have you're going to have greater luck having more robust resources with your local extension and land grant universities. So with that, I just want to bring the presentation to a close. Hopefully you gain a better understanding of some of the diseases you see as a seed all the way to the head. There are some management tools in here that you can further research on your own, either looking at those 3 resources I provided earlier in the presentation, or really working with your local extension and land grant university. So thank you for your attention. Appreciate taking a view of this day, and please reach out to me if you have any other further questions.